Okay, today we're going to be looking at solving systems by substitution. So what are you going to learn today? You're going to learn to solve it by substitution. Okay, so let's review real quickly. A system is two or more equations that are taken together. Okay, and we've only learned to solve them by graphing at this point. Okay, and remember that when we graph them, we can get three different kinds of solutions. We can get one solution where it's consistent and independent. That's where the lines on the graph will intersect. We can get infinitely many solutions which are consistent and dependent, which gives us one line when we graph it. And we can get no solution, which we say is inconsistent, and that would be when the lines are parallel and they do not intersect. So remember, if it's consistent, there's a solution or infinitely many solution. If it's inconsistent, there are no solutions. So last night you did graphing, solving by graphing. But why do we need other methods? Well, take a look at this system that I have graphed here. The system's for y equals 4x plus 2 and y equals negative 2x minus 3. If you look at where the solution is, okay, you should notice that it's not at a point where we can actually tell what the solution is. It's somewhere between negative 9/10 maybe for x, and y is maybe negative 1 1/3. But it's really hard to tell because it's not on the lattice point. And a lot of the things in the real world are not on the lattice point. So it's really important that we know how to use other methods to solve. So we're going to learn to solve it by substitution. You have all these steps written down. I'm not going to go through them. If you don't have your notes with you and you need to pause it, go ahead and pause it. It's not going to make much sense until I actually go through some examples. So here I have a system, y equals 2x and 7x minus y equals 15. Notice I have those little brackets around both. It means that that's a system. It's just one way that we can identify one. So what I'm going to do is I'm going to take, because I've got my first equation already solved for y, I'm going to substitute 2x in for y in the second equation, so that I'm going to get 7x minus 2x equals 15. And then you guys know how to solve that. We've been doing this since the beginning of the year. 7x minus 2x is 5x. We get 5x equals 15. If I divide by 5, x will be 3. So now I have the x value. I want to find y. Well, we call this substitution because we're going to substitute again. We're going to take our x value for 3, and I'm going to put it, we can pick whatever equation we want, but we want to make it simple for you. So I'm going to put it into the first equation because it's already solved for y. And if I substitute in, I'm going to get y equals 2 times 3, because I substituted into that y equals 2x, and that's going to give me 6. So my solution is the ordered pair 3, 6. So x would be 3 and y would be 6. And you can use either of these methods for writing your solution down. In this case, both of my systems are already solved for y. So I can take my 2x and I can sub it in for y into that second equation. Okay. Or sometimes I say that we set these two equal to each other. So 2x plus 2 equals negative 3x plus 4. And again, you know how to solve that. Let's just add 3x to both sides. And I'm going to get 5x plus 2 equals 4. I'm going to subtract 2, so I get 5x equals 2. I'm going to divide by 5, x equals 2/5. So we're going to leave it as 2/5. It doesn't matter now what equation I substitute in for. They're both solved for y. So let's take the easier one. I'm going to just put it in the first one. It's a fraction. I'm not sure which one really is easier. It's not going to cancel out. So y equals 2x plus 2, and I'm going to put 2/5 in for the x. So y equals 2 times 2/5 plus 2. So y equals 4/5 plus 2. Remember, 2 is equivalent to, in fifths, 10/5. So 4 plus 10, because I just add across the top, is 14. So 14/5. So my solution is going to be 2/5 and 14/5. So this graph will intersect at that point. Right. Now in this example, notice that we don't have either equation solved for a variable. So we need to solve one of them for a variable. I'm going to choose to solve the first one for y because there's no coefficient in front of the y and it makes it easier. So I'm going to take that first equation, the 2x plus y equals -1, and I'm going to solve it for y. So I'm going to add 2x to both sides, and I'm going to get y equals 2x minus 1. Now that I've done that, I'm going to take this 2x minus 1 and I'm going to put it in for the y in the second equation. It has to go into the equation that you did not solve. So if I substitute it in, I'm going to get 4x plus 2 times 2x minus 1 equals 12. So I'm going to get 4x plus 4x minus 2 equals 12. If I combine my like terms, I'm going to get 8x minus 2 equals 12. If I add 2 to both sides, I'm going to get 8x equals 14. And if I divide by 8, I'm going to get x equal to 7/4 because 2 goes into both of those. Right. Now that I have my value for x, I can find y. And I said that you could put it into any equation of the first two. Since we took the first one and we transformed it into this y equals 2x minus 1, we can also use that one as well. And since it's already solved for y, it's probably the easiest one to do. So I'm going to put my 7/4 into that third equation for x. So now if I multiply across 2 times 7/4, remember I can cross reduce, 2 goes into both of those. So I'm going to get y equals 7/2 minus 1. 1 is the same as 4/2. I'm sorry, 2/2. And 7 minus 2 is 5. So my y value is 5/2. So my ordered pairs are 7/4 and 5/2. Last example. This time notice that I've got the first equation solved for x. So I'm going to put 1/3 y plus 2 in for x in the second equation. So it doesn't matter if you solve for y or x. I know you guys are kind of conditioned to solving from y after doing all the graphing that we've been doing, but if it's easier to solve for x, you want to solve for x. So I'm going to put that in for my x, -3, and then times 1/3 y plus 2, then plus my y equals -6. If I distribute the -3, -3 times 1/3 is just -1, and -3 times 2 is 6, so -6 plus y equals -6. -1y, if I combine my like terms and positive y, cancel each other out, so I get -6 equals -6. My variables have disappeared, and that's a true statement. So just like in equations, that means we're going to have any solution, anything is possible. But we don't say all real numbers for this because they have to be paired. 3 can't just be paired with anything. 3 has to be paired with a different ordered pair. So we say that this has infinitely many solutions. And I'm okay with you guys abbreviating infinitely many solutions with IMS, infinitely many solutions. Now, if we solve this and the variables all disappear and we get a false statement, then again, this would be no solution. Those lines would be parallel if you were to graph them. In this case here, the lines would be the same thing if we graph them. All right, so here are those steps again. The first thing we want to do, if it's not already done, is we want to solve one equation for either x or y. Second thing is we want to sub our expression for x or y that we got in step 1 into our other equation, and we want to solve for our variable. Once we've solved for one of the variables, we're going to put that value into any of the equations and get the other variable. So the directions are kind of, you have to kind of, I think, see in order to understand the directions. Welcome back into the new year, and I want you guys to have a math-tastic day.